Welcome to ChemVid. Today we're going to focus on covalent bonding and how we show how nonmetals bond together and share electrons is through what we call Lewis dot structures. So we're going to save the first part of these notes for in class. So go ahead and turn to the second page where it talks about Lewis dot structures. This is how we symbolize how each covalent molecule comes together. And we're going to focus on that for today's lesson. Okay, so for today, we need to review a couple of things. As you recall, every atom wants 8 valence electrons total. That's what makes an atom stable, which is why atoms form bond, is for stability. So, unlike ionic, where we can switch electrons in order to form ions and they can fill their outer shells, covalent bonds share electrons and they actually form bonds, real bonds. So what I need to do is I need to look at each individual atom, see how many valence electrons it has to bond with, because valence electrons are the only electrons that bond, and then I can see how they go together. Okay? So if you look over here, here are the steps to Lewis dot structures. We call them Lewis dot diagrams. Small change there. So, the first thing I want to do is count the number of valence electrons for every element. So I'm going to start with H2O. I have an H and I have an O. There are 2 H's and 1 oxygen in every H2O. So if I look at the periodic table, I can see that hydrogen is in group 1. Therefore, it has 1 valence electron. So 1 valence electron for hydrogen. Since there are 2 of them, I'm going to multiply that by 2, and I get a total of 2 electrons from hydrogen, 2 valence electrons. For oxygen, I look over here, and it's in group 16. So that means it has 6 valence electrons. There are only 1 of them, so that's 6 total. I'm going to add these 2 together. And that gives me 8 total electrons. Now, you may think that all of my Lewis dot structures have to equal 8 because we want 8 valence electrons. That is not the case. That is sheer coincidence for this specific molecule. You'll find that it's the same for a lot of them, but they don't have to add up to 8. Okay? All right, so now that I found out that I have 8 total valence electrons for bonding, I can start spreading them out. So the next thing I need to do is put the first atom listed in the middle, unless it's hydrogen. Remember, hydrogen is the exception to every rule, and Lewis dot structures are, that it's no different. Okay? So I'm going to look at my molecule and see how it says H2O. Well, I would put hydrogen in the middle except for hydrogen is the one exception. So instead, I'm going to put oxygen in the middle. Place all other atoms around central atom. So I am going to place the hydrogen over here and a hydrogen over here. Okay? Now, if you notice, they are as far apart as they can be. That's because, of course, electrons don't like each other, right? They repel. Okay, now I drew it I cleaned up my page a little bit so it's easier to follow. So now I go to number 3. Place extra electrons on outside atoms first, then central atom. So what I'm going to do is I'm going to look at this bond. And in every bond, there are always 2 electrons in one bond. Okay? So for every bond, one atom is sharing an electron and another atom is sharing the electron, and so that's how you make a bond. So there are 2 electrons here and there are 2 electrons here for a total of 4 electrons in the bonds. Now, if you recall, H2O has 8 valence electrons total, okay? Which means that I'm missing 4 electrons. And I have to use up all of my valence electrons in bonding. So what happens is the extra electrons, or the electrons I'm not using in my bonds, they need to go on the outside atoms first, unless it's hydrogen. So, for emphasis, remember, hydrogen can only have one bond, which means it can only have 2 electrons total. So I can't put any extra electrons on my hydrogen. So instead, I'm going to start putting them on the central atom. So I have 4 valence electrons left over. So I'm going to put 2 up here on the top and 2 down here on the bottom. And that's just saying that my oxygen, since it doesn't need to make another bond, it's going to keep these electrons by itself. Okay? So now if I count up, I have 2 electrons in my bond, 2 electrons here, 2 here, 2 here, and that equals a total of 8 valence electrons, which is what I want. Okay? So now I have 4 electrons in my bonds and 4 electrons in what we call lone, that's an N, pairs. Okay? So lone pairs just mean that the electrons are on an atom, not in a bond. Okay? Unless it is hydrogen. So, for emphasis, hydrogen can only have one bond. It can only have 2 electrons because of how small it is. So you'll never, ever, ever, ever put electrons on hydrogen. So since I can't put my extra electrons on hydrogen, I'm going to put them on my central atom, which is oxygen. So I have 4 electrons used in bonds, and I have 8 electrons total, which means I need to put 4 electrons on my central atom, like so. Alright, so now that I have my electrons on there, I have 2 here, 2 here, 2 here, and 2 here, which equals 8. So check, I have as many valence electrons in as I have from my molecule used in my Lewis dot structure. So 4 electrons are in the bonds, and 4 electrons are what we call lone pairs. Meaning that these are the electrons that are not in a bond, but they are still part of the bonding process. Okay? So, if I count, hydrogen has 2 electrons, correct? That's good. That follows the octet rule. He has filled his first orbital, so he is stable. This hydrogen has 2, so he is stable. And then oxygen has 2, 4, 6, 8 electrons. And so therefore, he's stable. 2 in the bonds, 2 in the lone pairs. That is what we call checking for stability. So number 4, we want to check for stability, which includes make sure every atom follows the octet rule and is stable, and then check for what we call bending or shape. So the first one is what we just did. I made sure that every atom in my molecule has a full octet, so therefore it's stable. Now I need to check for what we call bending, or if it's going to have a different shape. Okay, so as you know, electrons don't really like each other. And if you notice, I have 2 lone pairs right next to a bond, right next to lone pairs, right next to a bond. And they don't really like that. So lone pairs, if I have a lone pair, they always bend the bonds. And what I mean by that is that these electrons, instead of being right on top of each other like this, they're going to bend the bonds with the hydrogen down slightly so that the lone pairs can come up here and have more room and less repulsion. Okay? So whenever you see lone pairs, you are always going to bend your molecule. Okay? So this is checking for bending, which I just did. So now I'm done with number 4. Oh, the third step. If an ion, put brackets and a charge. This is not an ion, it's a molecule, right? And we'll get to this third one in a bit, okay? So this is the correct Lewis dot structure for water. And if you could look at water and under a microscope, this is what you would see. You would see the oxygen with a strong negativity from the electrons up here. And then you would have hydrogens coming off like so. And we can see this through digital imaging. It's really cool, actually. All right? So that is how you draw a lone pair of electrons. That's how you draw your bonds. And altogether, you get a Lewis dot structure. These guys become very important when we talk about behavior. So let's give it a shot. Let's try ammonia. Okay, so ammonia is NH3. And I'm going to follow these same rules to draw that. Okay, so what I want you to do is pause the video, really pause it, and I want you to try drawing ammonia. Pause it now. Okay, so now after you have tried this, let's follow the rules. Number 1, count the number of valence electrons. Nitrogen has 5. Hydrogen has 1, but there are 3 of them, so I'm going to have 3. That is a total of 8. Again, that has nothing to do with the octet rule, it's just a happenstance. Then, number 2, put the first atom listed unless it's hydrogen. The first atom is nitrogen. And place all other atoms around the central atom, as far apart as they can get, remember, because they don't like one another. So I'm going to put them apart so it looks like a triangle, as far apart as they can get. Number 3, place extra electrons on the outside atoms first, unless it's hydrogen, then the central atom. So, these are hydrogens, so they're not going to go there. So I'm going to first count up my bonds. I have 2 electrons in this bond, I have 2 electrons in this bond, 2 electrons in this bond, which means I have a total of 6 electrons in bonds. That means that I have 2 electrons left over that need to be put on lone pairs. Now remember, lone pairs can't be put on hydrogen, so I'm going to put the lone pair on my nitrogen. Number 4, check for stability. Well, first of all, I'm going to count. Hydrogen has 2 electrons, which is perfectly fine. It has a full octet. Very good. This hydrogen's good. This hydrogen's good. And if I count nitrogen, I have 2 in this bond, 2 in this bond, 2 in this bond, and then I have 2 here, which equals 8. So nitrogen is all good. Now I need to check for bending. Oh, looky here. I have lone pairs. So the lone pairs are going to force these hydrogens to bend down a little. So I'm going to have my lone pairs all by themselves with lots of room. This hydrogen is going to bend down a little. This hydrogen is going to bend down a little. And then this hydrogen goes out straight. And this is the final Lewis dot structure for ammonia. All right. Check for stability. Check for everything. It's beautiful. And that's how it's done. And you follow these same rules for every molecule they give you, and you can draw any Lewis dot structure. So the reason why we draw Lewis dot structures is to see how molecules behave, and it's also what we look at for the molecular level. So whenever I ask you to draw a diagram of a covalent compound at the molecular level, you will be drawing the Lewis dot structure. Okay? Okay, so Lewis dot structures are part of our chemistry, is how we look at molecules, so they are very important. You're going to be drawing them a lot. So what I want you to do for homework is I want you to try drawing methane. Okay, so you should have methane drawn. I want you to try PCl3. And then I also want you to read over these rules that we went over. And I want you to know exactly what those rules mean, how they fit in drawing these Lewis dot structures. So when we practice drawing in class, you will know what you are doing. Okay? So just read over and make sure you know them. And then we will go over and practice these more in class. Thank you very much. Have a wonderful day.